Crash course on engineering, statics and dynamics. Learn about the principles of mechanics, including forces, motion, and energy. Sure, I'd be happy to provide a crash course on engineering mechanics, specifically statics and dynamics. Statics and dynamics are two branches of mechanics that deal with the behavior of physical systems under the influence of forces and motion. Statics deals with systems that are at rest or in a state of equilibrium, while dynamics deals with systems that are in motion. To understand these concepts better, let's look at some interesting examples and stories that demonstrate their applications in real life. Example 1. The Leaning Tower of Pisa. The Leaning Tower of Pisa is a famous example of statics. It leans at an angle of 5.5 degrees and has defied gravity for over 800 years. The tower's unique design, with its height and narrow base, makes it prone to tipping over. To prevent this, engineers had to calculate the tower's center of gravity and ensure that it was within the base's perimeter. They also had to dig deeper on one side of the foundation to counteract the lean. By using principles of statics, the engineers were able to create a stable structure that has become an iconic landmark. Example 2. Spacecraft trajectories. When spacecraft are launched into space, their trajectories are carefully calculated using principles of dynamics. Engineers have to account for factors such as gravitational forces, atmospheric drag, and the spacecraft's velocity and acceleration. They also have to ensure that the spacecraft reaches its intended destination with pinpoint accuracy. This requires a deep understanding of Newton's laws of motion, orbital mechanics, and other principles of dynamics. Now that we have a better understanding of the real-world applications of mechanics, let's dive into the top 12 principles of mechanics. 1. Newton's laws of motion. These laws describe the relationship between an object's motion and the forces acting upon it. They are fundamental to the study of mechanics and are essential for understanding the behavior of physical systems. 2. Forces. Forces are the agents that cause objects to accelerate or change their motion. They can be categorized as contact or non-contact forces and are measured in units of newtons, N. 3. Friction. Friction is a force that resists motion between two surfaces in contact. It is essential to the functioning of many machines and can be calculated using the coefficient of friction. 4. Moments and torques. Moments and torques describe the rotational motion of an object. They are measured in units of Newton meters, nanometer, and are essential for understanding the behavior of machines such as gears, engines, and turbines. 5. Center of mass. The center of mass is the point at which an object's mass is concentrated. It is essential to the study of mechanics, as it can be used to calculate an object's stability and equilibrium. 6. Work and energy. Work is the product of force and distance, while energy is the ability to do work. These concepts are essential to the study of mechanics and are used to describe the behavior of physical systems. 7. Power. Power is the rate at which work is done or energy is transferred. It is measured in units of watts, W, and is essential to the study of machines and engines. 8. Linear momentum. Linear momentum is the product of an object's mass and velocity. It is conserved in closed systems and is essential to the study of collisions and other dynamic processes. 9. Angular momentum. Angular momentum is the product of an object's moment of inertia and angular velocity. It is conserved in closed systems and is essential to the study of rotational motion. 10. Kinematics. Kinematics is the study of motion without regard to the forces that cause it. It is essential to the study of dynamics and is used to describe the behavior of physical systems. 11. Elasticity. Elasticity is the ability of a material to return to its original shape after being deformed by an external force. It is essential to the study of mechanics and is used to design materials and structures that can withstand stress and strain. 12. Fluid mechanics. Fluid mechanics is the study of fluids in motion and at rest. It is essential to the study of engineering, as it is used to design and analyze systems such as pipelines, pumps, and turbines. These 12 principles of mechanics are just the tip of the iceberg when it comes to understanding the behavior of physical systems. There are many more concepts and laws that engineers and scientists use to design and analyze the world around us. In summary, mechanics is the study of the behavior of physical systems under the influence of forces and motion. Statics deals with systems that are at rest or in equilibrium, while dynamics deals with systems that are in motion. Engineers and scientists use principles of mechanics to design and analyze everything from buildings and bridges to spacecraft and engines. And now, as promised, a poem about mechanics. Mechanics, the science of machines, of forces and motion and things in between. Statics and dynamics, two branches we see. One at rest, the other in motion, let's agree. Newton's laws, the cornerstone of mechanics, they set the tone. Forces, friction, moments too. And the center of mass, important to view. Work and energy, power as well. Linear momentum and angular, we can tell. Kinematics, elasticity, and fluid mechanics. Concepts that apply to structures and hydraulics. In the world around us, mechanics is key. From bridges and buildings to spacecraft and trees. Understanding its principles, we can design a better future for all, one that's truly divine. Start planning your next global adventure with ease and convenience with our Booking.com referral link. https://www.booking.com/index.html $aid equals 79893335 as a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for kind support our AnHub Metaverse channel, and please watch more interesting videos here.